Hi everyone, welcome to Chemex channel. Usually we only check the brand and type when buying cooking oil, but few people know that a bottle of clear edible oil has to go through a key refining process from crude oil to finished product. And there are two major technical methods in refining: physical refining and chemical refining. Many of you might mix them up and also wonder how physical refining cleans up the oil. Today we will first break down the core differences between the two, and then walk through entire physical process step by step with a 3D animation, and finally talk about which raw material it is suitable for and its advantages. Let's quickly clarify the key differences between them. It all boils down on two words: deacidification. Chemical refining relies on alkali neutralization. It uses food-grade alkali to turn free fatty acids in crude oil into soap stock for removal. This process uses chemical reagents and requires multiple water washing for impurity removal. Physical refining, on the other hand, takes the distillation deacidification route. It completely relies on high temperature and vacuum physical methods to evaporate free fatty acids without any chemical reagents throughout the whole process. It's more like giving oil a steam spa. Simply put, one removes impurities through chemical reactions, the other through physical separation and purification. That's the most essential difference. Now that we understand the difference, let's dive the complete physical refining process. Following the steps in the footage, it is actually not completed at all. Step 1. Deguming. This is the first step you see in the footage. Freshly pressed crude oil contains a lot of gums like phospholipids. These substances make the oil cloudy and prone to spoilage. So first, we heat the crude oil and then add hot water or phosphoric acid to make the gum coagulate into flocculants, which are then separated by sedimentation. Look, the stop setting at the bottom in the footage is the separated gum sludge. This step makes the oil a bit clearer initially. Step 2. Quality improvement. Bleaching. Although the degummed oil has had gums removed, it still has many pigments, such as carotene and chlorophyll, so it looks quite dark. That's when it enters the bleaching tank. And we add absorbents like activate clay and activate carbon. Those absorbents are like super sponge that can firmly absorb pigments and some impurities in oil. After thoroughly stirring, we filter out the clay that has absorbed impurities using a leaf filter. This step not only improves the oil's appearance but also reduces the burden of subsequent deodorization. Step 3. Pretreatment. Filtration before deodorization. The bleached oil still has tiny clay particles left, so after drying, it goes through a precession filtration to completely remove the remaining fine clay particles. This ensures the oil entering the next step is clean enough and avoids affecting the efficiency of the subsequent equipment. Step 4. Core step: distillation, deacidification, and deodorization. Single tower, two-stage type. This is the sole step of physical refining. The tall tower in the footage is the refining tower that integrates deacidification and deodorization functions. It has a bottom deacidification, top deodorization design, which is extremely efficient. First, look at the deacidification section at the bottom of the tower. The cleaned oil enters from the middle lower part of the tower. At the bottom, it is heated to 240 to 260 Celsius by high temperature heat transfer oil, and the tower maintains a high vacuum state. Residue pressure usually no more than 600 bar. Under these conditions, free fatty acids in the crude oil turn into vapor and then evaporate. But since their volatility is relatively low, they move up a short distance and then get collected. The oil left at the bottom of the tower is the deacidified oil. Then the deodorization section at the top of the tower, the deacidified oil continues to flow upward, and a small amount of the superheated steam is injected from the top of the tower. Under high temperature and vacuum, The steam acts like porters, carrying more volatile odorous substances to quickly separate from the oil phase. Finally, they are discharged from the top of the tower and condensed for recovery. Look at the animation. Free fatty acids evaporate from the lower part, and odorous substances are carried away by steam from the upper part. It's really clever how one tower completes two core processes in one go. Step 5. Final purification, filtration, and cooling. The last step is the finishing touch. The deodorized oil is quickly cooled to below 60 Celsius and then go through another filtration to remove any possible trace, plumbers, or impurities. Now the entire physical refining process is complete. The oil flowing out in the footage is the clear, light-smelling, and stable quality finished edible oil. After watching the process, let's highlight the key points. Which raw materials is physical refining suitable for, and what irreplaceable advantages does it have? First, suitable raw materials. It's most good at processing high-acid vegetable oils, such as palm oils, rice bran oils, sunflower seed oils, and some low-quality crude olive oils. These oils have high free fatty acid content. Using chemical refining would produce a lot of soap stocks, leading to high loss and waste. But physical refining directly removes acids through distillation, and the loss is more controllable. It's basically tailor-made for them. Now the core advantages. Number 1. More natural and pure. No chemical reagents are used throughout the process, and no water washing is needed. This avoids chemical residues and water consumption, so the finished oil can better retain its original natural flavor and nutritional components. Number 2. Lower loss and more economical. When processing high-acid oils, unlike chemical refining, which loses a lot of neutral oil due to soap stock entrainment, physical refining can return more valuable oil. At the same time, it can recover high-quality free fatty acids, maximizing resource utilization. Number 3. More environmental friendly process. There is no soap stock wastewater discharge, so the subsequent treatment cost is low, which meets the needs of grain production nowadays. Number 4. But it has scale requirements for equipment. The equipment and process characteristics of the physical refining mean it's not suitable for small-scale production. Generally, the minimum processing capacity needs to reach 3 tons per day. Currently, there are no mature smaller-scale equipment solutions, so it is more suitable for medium and large oil processing enterprises. To sum up, physical refining uses the single tower's two-stage high-temperature vacuum distillation technology, combined with steps like bleaching to turn high-acid crude oil into pure finished oil. It not only has strong adaptability but also has the advantage of being natural, economical, and environmentally friendly. However, it's more suitable for production with a certain scale. Now, when you look at the cooking oil at home, do you have a clearer understanding of the refining behind it? If you have any questions about oil refining, feel free to leave your comment. Don't forget to like and save if you enjoyed today's content. See you next time.